Assalamualaikum warahmatullahi taala wabarakatuh. So our group we present about sustainable products. So the content for this presentation, first we have rice husk. After that we have coconut fiber. So for the first I will present about the rice husk. So the introduction, in the field of construction we are no strangers to materials such as cement, granite and so on. In past studies there was a lot of pollution and wastage going on. They get the idea to use waste materials in construction, natural resources and the protection of the environment. Furthermore, there are studies that a suitable waste material in the cement manufacturing is ash. In the rice manufacturing industry, there are waste materials like rice husk ash. So the objective, first to investigate and compare the influence of weight replacement and volume replacement of fine aggregates by rice husk ash on workability, brute density and compressive strength. Second, to assess the suitability of rice husk concrete in construction. For the methodology, first we have workability test. The procedure is the percentage of rice husk ash with 0%, 5%, 10% and 50%, 20% and 25%. Take their weight and volume. After that, take the weight and volume of concrete mix proportion with ratio 1:4. After that, measure the cubic specimen and mix the concrete. After that, compact in the concrete mix in the cubic, compact in the 3 layers. After that, demold the samples for 24 hours and keep the sample in the water tank. After that, take the data. So next we was compacting factor test. The concrete cube carried out with the comp test, which is crushing machine. Take the sample weight. After that, put the sample in the compressive test machine. And lastly, take the data.
So this is the result for rice husk that we get from the journal. We get to compacting factor, bulk density of weight, bulk density of volume. Graph bulk density of weight, graph bulk density of volume. Table and graph compressive strength of weight, table and graph compressive strength of volume. And lastly, recommended grade of concrete. Discussion. The workability of the volume-based concrete produced by volume replacement of sand by rice husk is higher than the produced by weight replacement. Since sand is denser than rice husk, replacement by an equal mass of rice husk lead to a large increase in volume. The replacement by an equal volume of sand. Increase in the quantity of rice husk increase the specific surface area. Thereby, more water would be required. It can be observed that in both mix, the density of concrete reduced as percentage content of rice husk increase. However, the density of both mix increased with age of the curing. The maximum density occur at no replacement 100% sand, while minimum density occur at 25% rice husk replacement. It can be observed that the compressive strength decrease as the rice husk content increase. The compressive strength is maximum at 0% replacement by rice husk and minimum at 25% replacement. As rice husk content increase, the specific area increase, thus requiring more cement paste to bond effectively with the husk. From the investigation carried out, the following conclusion can be made. There exists a high potential for the use of rice husk as fine aggregate in the production of lightly reinforced concrete. Weight-based rice husk concrete and volume-based rice husk concrete show similar trend in the variation of bulk density, workability, and compressive strength. Loss of bulk density, workability, and compressive strength is higher for weight-based rice husk concrete than volume-based rice husk concrete.
Okay, so next is recommendation. The researchers can contribute to more economical development and stronger development. The researchers could not conclude that rice husk ash could be used in construction, but they still are confident that it will succeed because it has high potential. Perhaps the disadvantage of this study, the low use of rice husk ash. In this study, it lacks knowledge for rice husk ash. They can improve this study by making a study on rice husk ash first before applying the test for construction. For this study, we can suggest that the researchers can conduct a more in-depth study on their test material, that is rice husk ash, to get more regular data and suitable for construction.
Okay, so I will continue about coconut fiber in concrete. Coconut fiber is biodegradable and the most ductile among all natural fibers that has the potential to be used as a reinforcement material in concrete. By using coconut fiber as material in construction, it can be disposed of and not leaving as a waste materials. Coconut fiber also is not expensive, always available, and make environment more efficient by reuse it in construction. It also can be used as one of the concrete ingredients by replacing the coarse aggregate to make a partial concrete. There are two types of coconut fiber that are used in construction, which is raw material fibers and processed material fibers. So the objective is to identify the improvement in strength characteristic of concrete with the addition of all coconut fiber, to study its effect on flexural, compressive, and tensile strength properties, and also drying shrinkage, and to produce a sustainable concrete for construction in economical way. Okay, so this is the methodology of compressive strength test. The next one is methodology of tensile strength test, and the last one is methodology of flexural strength test. Okay, so this is the result of compressive strength test. This is without addition of coconut fiber, and this is with addition of processed and raw coconut fiber. As you can see here, the difference between them is the compressive strength of addition of coconut fiber is more than compressive strength of without coconut fiber addition. So this is the result of the tensile strength test. It is the same as the compressive result. So the tensile strength for with addition of coconut fiber is more than the tensile strength without coconut fiber. And this is the flexural strength test. It's same, and the flexural strength is for addition coconut fiber is more than without coconut fiber. Okay, so for discussion, from the data, the best result for yield compressive strength is at 5% addition of coconut fiber with water cement ratio of 0.5, but compressive strength decrease on further addition because there is an optimum value of fiber to cement ratio. Next, for split tensile strength, it is increased when the percentage of coconut fiber is maximum at 5%, but it has a reduction after the maximum value because of the tensile failure that occur due to the dislocation of atoms and molecules present in concrete. Lastly, for flexural strength test, it is also increased at addition of coconut fiber at 5% and decrease when added more addition because of the binding properties of among coconut fiber owing to its high tensile strength of 21.5 megapascal.
From the investigation carried out, the following conclusion can be made. The research conducted and conclusion reached by various researchers over the past few decades and also briefly presented. This journal also includes graphs that illustrate the connection between various properties. Composite with reinforced coconut fibers have been used as affordable non-structural components because of their durability. The purpose of this review is to increase awareness of the use of coconut fibers in civil engineering construction. The advantages of coconut fiber in a construction are of all natural fibers, coconut fiber has the highest level of toughness. Because of their durability and toughness, these core fibers serve as reinforcement in low-cost concrete structures, especially in earthquake-prone areas. Core fibers offering effective insulation against temperature and sound, humidity and other environmental factors have no effect on them. They serve as reinforced material by strengthening the composite. Lastly, the advantages of fiber reinforced concrete in a construction includes the following, which are: rain might expose the fibers, so the concrete will not long lasting. Fibers randomly orient in the concrete and could result in poor quality concrete if not uniform. This is the recommendation for this investigation, which is first, since Malaysia's scarcity of natural resources like ban on quarrying due to environmental hazard have forced the construction sector to seek for another alternative in concrete production. The researchers can conclude that coconut fiber could be used in construction. As the result, graph and analysis in the journal is very detailed, so they are confident that it will succeed. In this research, the researchers did not fully know information in detail about advantages and disadvantages of coconut fiber, so they should improve this problem by making more study on coconut fiber first before applying the test for construction to avoid error information. The sample of concrete production using coconut fiber is so limited, so I think the researchers could conduct a lot of samples so that we know the result is more accurate and approved to be used in a construction. So lastly, the references of our investigation is through first YouTube, second journal, and third website. That's all from us. Thank you.